Math, the apple of my eye, with Mr. McWhorter. Let's talk about absolute value equations and inequalities. The absolute value of a number, written like this, absolute value of x, is the distance from that number to 0 on the number line. That's always going to be a positive value, or 0. It's never going to be a negative value. Absolute value of 4 is 4. The absolute value of negative 4 is 4, because they're both 4 units away from 0. See, both 5 and negative 5 are 5 units away from 0. So they both have an absolute value of 5. An absolute value equation has a variable inside the absolute value. So the absolute value of x equals 5. There's two numbers that could go in there. The absolute value of 5 is 5, and the absolute value of negative 5 is 5. So we would say the solution to this equation, absolute value of x equals 5, you would say x equals 5 or x equals negative 5, because there's two different values that could work. What is the solution of the absolute value of 2x minus 1 equals 5? Well, here's what I want you to think about. The absolute value of something equals 5. So what numbers can this equal? It can equal 5, or it can equal negative 5. So I'm going to say that 2x minus 1 has to equal 5, or 2x minus 1 has to equal negative 5, because you can have either a 5 or a negative 5 in here. So that means 2x minus 1 has to equal 5, or 2x minus 1 has to equal negative 5. Now I just solve each one of these. Plus 1, plus 1, get 2x equals 6, 2x equals negative 4, divide by 2, divide by 2, and I get x equals 3 or x equals negative 2. So those are my solutions graphed on a number line. Now people are known to make little mistakes with this, so I would always check and make sure that your answer works. So we're going to take these values, so take the 3 and plug it back into the original equation. Does the absolute value of 2 times 3 minus 1 equal 5? Well, 2 times 3 is 6. 6 minus 1 is 5, and the absolute value of 5 is 5. Sweet. How about negative 2? Does that really work? 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. Absolute value of negative 5 is 5. Alright, pause and see if you can figure out this guy. Push play when you're ready to see the solution. Alright, so the absolute value of 3x plus 2 equals 4. That means that 3x plus 2 has to equal 4 or negative 4. So 3x plus 2 equals 4, or 3x plus 2 equals negative 4. Subtract 2 from both sides, and I get 3x equals 2. Then divide by 3, and I get x equals 2/3. Here, subtract 2 from both sides, and I get 3x equals negative 6. Divide both sides by 3, and I get x equals negative 2. Then I want to just check and make sure that those really work. Absolute value of 3 times 2/3 plus 2 equals 4. 3 times 2/3 is, these 3's cancel, and I get 2 plus 2. The absolute value of 2 plus 2 is going to equal 4. What about the negative 2? Absolute value of 3 times negative 2 plus 2, does that equal 4? 3 times negative 2 is negative 6. Does that equal 4? Negative 6 plus 2 is negative 4. Absolute value of negative 4 is 4. So both of those work. So my answer is those. Alright, so now we have a multi-step. Well, in order to solve a multi-step absolute value of an equation, we have to sort of pretend that this is its own little variable for now, and then we're going to solve it as though it was like 3y minus 1 equals 8. What would we do? We would add 1 to both sides, divide both sides by 3, and then we can say, all right, well, this equals 3. Well, what was it? It was absolute value of x plus 2. So my absolute value of x plus 2 equals 3. And now I've reduced it to a problem that I already know how to do. Just be really careful, because you're going to be tempted to distribute this 3 through here, and you're not allowed to do that. This means absolute value. It's not just a grouping symbol. You have to get this whole absolute value by itself before you can start doing anything else to solve this problem. Never try to distribute through an absolute value. It doesn't work. You'll get one solution right and one solution wrong. That's usually what will happen. So what do? We're going to add 1 to both sides, divide both sides by 3, and we've got the absolute value of x plus 2 equals 3. Once the absolute value is by itself, now we can say that the inside here has to equal 3 or negative 3. So we get our two equations. X plus 2 has to equal 3, or x plus 2 has to equal negative 3. And now we can just solve those. Subtract 2 from both sides, and we get x equals 1 or x equals negative 5. Now, especially in problems like this, you want to plug those solutions in and make sure that you didn't make mistakes. There's your graph. Plug them in. 3, plug them back into the original equation. Okay? 3 times the absolute value of 1 plus 2. Well, 1 plus 2 is 3. So that's going to be 3 times the absolute value of 3 is 9. 9 minus 1 is 8. So we're good with that one. Let's check the other solution. Negative 5 plus 2 is negative 3. Absolute value of negative 3 is 3. 3 times 3 is 9. 9 minus 1 is 8. So we did good. Pause. See if you can do number 2. Push play when you're ready to see it done. Okay, so the first thing we're going to do is distribute this 2. Heck no, we're not allowed. We got to get this absolute value by itself. You cannot distribute through an absolute value. It's against the law. So I'm going to subtract 3 from both sides. And then I got 2 times the absolute value of x plus 9 equals 4. Then I'm going to divide both sides by 2. And I get the absolute value of x plus 9 equals 2. Well, that means that x plus 9 has to equal 2 or negative 2. So x plus 9 can equal 2, or x plus 9 can equal negative 2. Subtract 9 from both sides. You get x equals negative 7, or subtract 9 from both sides, and you get x equals negative 11. Now I want to plug those into my original equation and make sure they work before I just say, I'm done because I'm awesome. Okay, so 2 times the absolute value of negative 7 plus 9 plus 3, does that equal 7? So this is 2 times the absolute value of negative 7 plus 9 is 2 plus 3. Does that equal 7? Absolute value of 2 is 2. 2 times 2 is 4. And 4 plus 3 definitely equals 7. Alright, what about the negative 11? let's do 2 times the absolute value of negative 11 plus 9 plus 3, and ask ourselves, does that equal 7? Negative 11 plus 9 is negative 2. So does this equal 7? The absolute value of negative 2 is 2. So this is 2 times 2 plus 3. 4 plus 3 definitely equals 7. Alright, so let's do this. The absolute value of 3x plus 2 equals 4x plus 5. The absolute value is by itself. So the inside has to equal either positive 4x plus 5 or negative 4x plus 5. So what does that look like? 3x plus 2 can equal 4x plus 5, or 3x plus 2 can equal the negative of 4x plus 5. That means we have to bring the negative through to both parts. So let's simplify that. If we were to subtract 4x from both sides, we would get negative x here. Subtract 2 from both sides, we get 3 there. So we get x equals negative 3 or x equals negative 1. What do we always want to do with absolute value equations? Check. Check in the original equation. Does the absolute value of 3 times negative 3 plus 2 equal 4 times negative 3 plus 5? Well, this is going to be negative 9 plus 2, negative 12 plus 5. This is going to be the absolute value of negative 7. Negative 12 plus 5 is negative 7. But the absolute value of 7 is 7, and that does not equal negative 7. So this is what we call an extraneous solution. The x equals negative 3 is an extraneous solution. So we don't count that because it doesn't actually work. But let's check and plug in with the negative 1. 3 times negative 1 is negative 3. 4 times negative 1 is negative 4. Negative 3 plus 2 is negative 1. The absolute value of negative 1 is 1. 1 equals 1. So we're pumped. Since x equals negative 3 does not satisfy the original equation, it is an extraneous solution. The only real solution to the equation is x equals negative 1. Pause. Try this out. See if you can figure out what the solutions or solution is. Push play when you're ready to see it. Okay, the absolute value of 5x minus 2 equals this. So 5x minus 2 equals 7x plus 14, or 5x minus 2 equals the negative of 7x plus 14. I'm going to subtract 7x from both sides here. Actually, no, I'm not. I'm going to subtract 5x from both sides, because that'll give me 0 here and a positive x's here. So negative 2 equals 2x plus 14. Subtract 14, and I get negative 16 equals 2x. Divide by 2, and I get negative 8 equals x. Save that for a minute. 5x minus 2 equals negative 7x minus 14. Add 7x to both sides, and I got 12x minus 2 equals negative 14. Add 2 to both sides. 12x equals negative 12, so x equals negative 1. I need to check those. My original equation was absolute value of 5x minus 2 equals 7x plus 14. So I'm going to check the negative 8 first. Negative 8. So 5 times negative 8 is negative 40. Minus 2, that's negative 42. 7 times negative 8 is negative 56 plus 14. And I get 42 equals negative 42. Not okay. So this is an extraneous solution. So absolute value of 5 times negative 1 minus 2. Does that equal 7 times negative 1 plus 14? 5 times negative 1 is negative 5. Negative 5 minus 2 is negative 7. 7 times negative 1 is negative 7 plus 14. The absolute value of negative 7 is 7. Negative 7 plus 14 is 7. So we're good. So the only solution is x equals negative 1. Alright, now we're going to talk about absolute value inequalities. It's beneficial to remember that absolute value means distance from 0. So when you see the absolute value of x is less than 5, what you should be hearing in your head is the distance from 0 is less than 5 units. So that means, so here's 0. The distance away from 0 is less than 5 units. The distance away from 0 in this direction is less than 5 units. So any number in between there satisfies the inequality. Any number that's not negative 5 or less, or that's not 5 or more, is going to be less than 5 units away from 0. So this is a graph of all your solutions. And the way you can write that solution is negative 5 is less than all of our solutions, and our solutions are all less than 5. Another way to say that is that our solutions are between negative 5 and 5. X is greater than negative 5 and less than 5. So how does that extend to when it's not just an x inside here? Well, if it was just an x inside there, we would be able to say negative 5 is less than x less than 5. Well, we can do the same thing, except instead of just x, it's 2x minus 1. Now, what we can do is consider this like a three-sided inequality. We still want to get x by itself, so we're looking at the x. What's happening to the x? There's a 1 minus, there's a 1 subtracted, and then a 2 multiplied. So if I add 1 to all three parts of the inequality, I will get negative 4 less than 2x less than 6. Then, to get x by itself, all I would need to do is divide by 2. And then I would have negative 2 less than x less than 3. So my x values are in between negative 2 and 3, and that's what the graph would look like. So pause and see if you can figure out how to solve and graph this one. Push play when you're ready to see it done. Alright, so 3x minus 4 is going to be less than 8 units away from 0. That means it's going to be in between negative 8 and positive 8. And you just have to keep the same sign here. If it's got to equal 200, then you got to have equal 200. Add 4, add 4, add 4. I got negative 4 is less than or equal to 3x less than or equal to 12. Divide by 3. And I get negative 4/3 is less than or equal to x, which is less than or equal to 4. If I was going to graph that, which I am, 0, 1, 2, 3, 4, negative 1, negative 2, negative 3. Negative 4/3 is negative 1 1/3. So negative 1 1/3 is about here, and it'll be a solid circle because it's less than or equal to. Then that has to be less than all my solutions, and then all my solutions are less than or equal to 4. Solid circle there, everything in between. So this is how you do it when the absolute value is less than a number, meaning that our solutions are less than a certain distance away from 0. So then what does it mean when we have absolute value greater than 5? Well, that would mean that if you imagine a number line, there's 0, there's 5, there's negative 5. This means our distance away from 0 is greater than 5. So our solutions are going to be more than 5 units away from 0. So that means 5 doesn't count, but everything that's more than 5 units away from 0 does count. To the right and to the left. More than 5 units away from 0 to the left looks like that. So how would we write that? We would say that x is less than negative 5. That's this. Or x is greater than 5. That's that. So how do we solve an absolute value inequality where the absolute value of an expression is greater than or equal to a number? Well, we just say the inside of the absolute value is less than or equal to the negative or greater than or equal to the positive. Just like we did here. Less than or equal to the negative, greater than the positive. And then we just solve like normal. Subtract 4 from both sides, divide both sides by 2. So that says that the x values have to be less than or equal to negative 5 or greater than or equal to 1. Pause, try number 5, push play when you're ready to see the solution. Alright, absolute value of 5x plus 10 is greater than 15. So that means that 5x plus 10 is less than the negative, so less than negative 15, or 5x plus 10 is greater than the positive 15. Subtract 10 from both sides. We get 5x is less than negative 25. Divide by 5. And we get x is less than negative 5. Or subtract 10 from both sides of this one. We get 5x is greater than 5. Divide by 5, and x is greater than 1. That's crazy. It's the same answers as we had up here. That's a trip. So the graph of that would just be, it would be this, but with empty circles, because it's not greater than or equal to. 0, 1, negative 5, open circle greater than 1, open circle less than negative 5. For B, without solving this, can you describe the graph of its solution? Well, it's greater than or equal to 2, so it's going to have solid circles and arrows pointing outward. We would probably have to solve to figure out what numbers these were, but that's going to be the shape of the graph. And the secret phrase for this video is snob hobbit. Snob hobbit. Okay, so here's a little summary. If the absolute value of x equals a number, that's the distance from x to 0 is exactly a units, then you get your solutions are negative a and a. If the absolute value is less than or equal to a, then we're going to be in between those values. And if the absolute value is greater than a, meaning distance from 0 is more than a, then we're going to be on the outside of those a values. We're going to be farther away from the center. let's explore for a second, shall we? Absolute value of x equals 5. That means the distance from x to 0 is 5 units. Absolute value of x minus 2 equals 5. So what does that mean? Does that mean the distance from x minus 2 to 0 is 5 units? That's one way of saying it. But maybe there's a better way to say it that maybe means a little something more. So when we solve this, we say, well, 5 or negative 5 could go in here. So x equals 5 or x equals negative 5. When we solve this, we say x minus 2 could be 5, or x minus 2 could be negative 5. Then we add 2 to both sides, and we get x equals 7 or x equals negative 3. Then we graph our solutions. So x equals negative 5 is about here, x equals 5 is here, and those are both 5 units away from 0. X equals 7. Oh wait, yeah, 0, there's the center. X equals 7 is there, x equals negative 3 is here, but what's right in the middle of those? Right in the middle of those is 2. And then each one of these is 1, 2, 3, 4, 5 units to the right, 1, 2, 3, 4, 5 units to the left. So that's kind of interesting that x, the absolute value of x minus 2, means that our solutions are 5 units away from 2. It's kind of cool, isn't it? So the distance, another way to say what this means is the distance from x to 2 is 5 units. So here's what we can say kind of in general. If we have a target value that's going to be at the center of our little range here, then we can say x minus the target value, absolute value, equals the distance away from the target. And we can use that to write absolute value inequalities that go along with real life situations. So in racing, the ideal height is 52 inches of your car, but you can be within an inch in either direction. So we're going to use this. X minus the target value equals the distance away from the target value that you're allowed to be. Another way to say that, so in this range, we don't want to say, well, we want to be exactly 53 or we want to be exactly 51. We need to be somewhere inside there. So that's going to be x minus our actual measurement, our actual height, minus the target value has to be less than or equal to 1 inch away. So another way to say that would be our actual value minus the target value is less than or equal to the tolerance. The tolerance is how far away you're allowed to be in one direction or another. So actual value minus target value less than or equal to the tolerance. So our actual value is the height of our car. The target value is 52 inches, and we have to be less than or equal to 1 inch away from that. So just using this, we can write an absolute value equation to model the real life situation. And if we were to solve this, we would end up getting this range here from 53 inches to 51 inches. Because you would put -1 less than or equal to h minus 52 less than or equal to 1. Then you would add 52 everywhere, plus 52 plus 52, and then 52 minus 1 is 51, less than or equal to the height of your car, less than or equal to 53. So the idea here isn't that we're solving this equation, it's that we're taking a real life situation and writing an absolute value equation to model it. So suppose that the least allowable height was 52 inches and the desirable height was 52.5. So 52 was the lowest you can be, 52 is the lowest you can be. 52.5 is the target. And then you can be another half inch in the other direction, which will put you at 53. We're going to do actual value, which is the height of the car. So absolute value of h minus the target value, 52.5, has to be less than or equal to the tolerance. And the tolerance here is only a half an inch, so 0.5. Well, I feel like I have corn coming out of my ears, so I think we're done with this lesson. Start on the practice problems. Make sure you do all those practice problems and check your answers to make sure that you're doing these things right. Email me with questions and then get on that formal write-up. I'll talk to you soon.